Hello everyone, my name is Yunus Gökberk Semiz. This video is a personal presentation of facial emotion recognition project done under the scope of METU EEE Star 2021-2022 and the supervision of Professor Dr. Engin Tuncer. Before we start, I want to give you a little bit of information about the project. The aim of the project is to solve one of the hardest problems of computer vision, emotion recognition from facial images and videos. To solve this problem, a deep neural network will be modeled with a very strong machine learning software named TensorFlow. In order to train this model, a dataset will be created. Later, this trained model will be implemented into a website. Hence, the final product is able to recognize your motion with the image you upload to this website. Since this is a large project done by a total of 9 students at different times, students are split into 3 groups. These are namely the data collection group, deep neural network group, and web implementation group. The data collection group is mainly responsible for gathering data used in training the model. Deep neural network group is responsible for creating, training, and testing the deep neural network. Web implementation group is responsible for the creation of the website and the implementation of the deep neural network, or DNN for short. And I'm the leader of the deep neural network group, DNN group. So in this video, I will mainly cover this section of the large project. The video consists of 3 main parts. In the first part, I will give technical background information on artificial intelligence and deep learning. In the second part, I will truly explain the deep neural network model creation process and training process. Then in the last part, it will be mostly about the testing of the model, optimization of the model, and the results. Okay, so in order to understand what neural networks are, first we need to explain AI, machine learning, and deep learning, as well as their differences. Artificial intelligence is basically the ability of a machine to imitate intelligent human behavior. As you can see from the graph, AI is the biggest set, which includes machine learning as well as other areas such as natural language processes, speech expert systems, robotics, etc. Most of these AI systems simulate natural intelligence to solve these complex problems. On the other hand, machine learning is a form of AI that learns from experience, in this case data, learns from data. After being trained, the model is tested and analyzed, and after this loop of retraining and analyzing and optimizing the model, we achieve an artificial intelligence model which can do complex tasks such as, in our case, recognizing and classifying different emotions. Now, there are 3 different ways of model learning types, and these are the unsupervised learning, reinforcement learning, and supervised learning. And an important thing to note is that these learning algorithms are not the difference between machine learning and deep learning. So let's talk a little bit about these learning types. So in supervised learning, the data is already labeled, which means you know the variable. Using this method of learning, systems can predict future outcomes based on the data. It requires at least an input and an output. But in unsupervised learning, the data is not labeled, hence the model recognizes these patterns on its own. And after these patterns become more and more applicable and readable, we can get the output of this model. On the other hand, reinforcement learning is a little bit different than the supervised and unsupervised learning. It trains an agent to complete task within a certain environment. You can think of it as a mouse that trapped in a labyrinth and tries to find the exit. And after each action done to the environment gives a reward from this action, and this reward measures how successful the action is with respect to completing the output goal. And deep learning is a sub-branch of machine learning. In traditional machine learning, humans need to extract information from images, such as in our case, the vital points like nose width, roundness of the image, color distribution, um, eye types, etc. This creates a problem where we have to determine which extracted information gives the better result in different applications by trial and error. It makes the AI applications more costly, especially time-wise. But in deep learning, humans create a artificial model, a DNN model that tries to imitate the way human brain works. It consists of very large amounts of artificial neurons. By connecting these neurons together in different ways, we can produce these unique deep neural networks. And these DNNs learn directly from the images. So we don't have to manually extract information from the data ourselves. The DNN makes it on its own. And we only need to create this suitable deep neural network architecture and the model for different applications, which reduces the time cost substantially. But the problem with deep learning is the complexity. Since we don't manually extract information from data, our model needs thousands of images. It also needs stronger computation hardware. We also don't know which information our DNN uses to learn such algorithms, and this makes optimization a lot harder and mysterious than in traditional machine learning. But all in all, since we have stronger and cheaper CPUs and GPUs, and we also have bigger data at our disposal than ever before, so these deep learning applications are only going to rise. And this fact makes deep learning the new upcoming problem solver. So, in order to understand deep neural networks, first we need to understand the backbone, the backbone of deep neural networks, the artificial neurons. These artificial neurons are simple mathematical functions that somewhat resemble biological neurons. They can store information just like biological neurons, and to do this, they get impulses with different weights from previous layer neurons and sum their values with a unique bias that can change over time. Later, this summation goes into an activation function. Most of the time, this is the sigmoid activation function. And if this summation gets activated by the function, it gives an output. And this output is the input of another artificial neuron in another layer. And before we move on to the deep neural networks, let's first discuss the artificial neural networks. These are the black boxes of deep learning applications. Artificial neural networks can be visualized as an artificial brain. It's made of artificial neurons, as you can see from the image. And these artificial neurons are consist of 3 to 5 layers. Every single layer consists of artificial neurons which are connected to all the other neurons in the next layer. Layers are usually is not usually, but always the same type of neurons, which makes it so that every layer has its own purpose. For example, one layer can collect the image, one can try to identify the image, one can try to randomize and harden the process in order to make the system more reliable, and one can simply store the input and output of the system. This system is connected with these layers, and the difference between the artificial neural networks and the deep neural networks are the size of these networks. Deep neural networks can be hundreds of layers long, while the artificial neural networks are only 3 to 5 layers long. There's a huge number of neural network architectures used for different problems and different applications, but out of these neural networks, we use the convolutional neural network architecture, since it imitates the animal visual cortex. Hence, in computer vision applications such as facial emotion recognition, convolutional neural networks are going to be used. And let's move on to the DNN creation process. We solved the facial emotion recognition problem with, as we talked previously, with supervised learning. So our data are labeled, and multi-class classifications, which means that there are multiple classes of these labeled data. and convolutional neural network. And our network takes an input image or video, detects the face in the image using an external tool named Haar Cascade, and gives a prediction as an output. And traditionally, such networks have 7 emotions to classify, but multiple studies found out that this approach of emotion recognition we use in our model can't accurately classify disgust and scared emotions. And thus our model is currently capable of detecting happy, angry, sad, surprised, and neutral emotion. And let's talk about datasets. Training datasets need to be diverse for a good deep neural network. For this reason, we used 3 datasets to train the model. The first one is the FAR 2013. It's arguably the most labeled, the most popular facial emotion dataset. It has 30,000 images. EffectNet is the biggest facial emotion dataset in the market. It has more than 400,000 images. We got permission to use the dataset with the help of our advisor, Professor Dr. Engin Tuncer. And the data group creates a novel dataset for us to use. Then I randomly selected images with different percentages from these datasets to create a diverse dataset, training dataset. And 1/7 of this data is used as the validation data in the model, and the rest is used as the training data in the model. The final product used nearly 38,000 images and as training images, and 6,000 as validation images. I selected these numbers by trial and error during the optimization. And now that we have our data, we need a tool to create the deep neural network. Working with these deep neural networks require strong and specialized CPUs and GPUs, as well as a lot of programs and libraries. I'm choosing these programs and versions manually for compatibility with our equipment. These are all the dependencies and programs I use in my work. So this image shows one of the first models being created. It's written in Python language and TensorFlow Keras tools. It's a relatively short model. It's only 12 layers long. It takes 48 to 48 grayscale images as an input, and after convolutions, pooling, dropout, and flattening, it scores the original 7 emotions from 1 to 0. The output is selected through softmax activation, which means the highest scored emotion becomes the output. And this image is an accuracy and loss map. It's creating during the training in order to optimize and get the best possible final model. We can't really use this map, since we need to compare tens or even hundreds of models. So we need another independent testing environment. And this is a confusion matrix. A confusion matrix is a table that shows how well a classification model performs on a set of datasets. However, the test data we used was also very important. Therefore, we prepared a dataset which contains 100 images per emotion, in this case 500 images total. And it is important that these images had no connection with our training and validation data. So for this reason, we collected these images from different and random websites on the internet. Then we split the faces from the images with the face detection algorithm Haar Cascade, and at the end of this data preparation, we got an independent and reliable test environment. In order to fully optimize the network, I had countless of trials, and after these trials, I found out that grayscale images are better than colored images, even though colored and grayscale training gives similar accuracy. Colored images take 3 times longer to train than grayscale images. I also tried different sizes of images from 48 to 48 to 512 to 512 pixel images in our training data, and I found out 128 pixel images gave the best result. I used the optimizer ADAM with a learning rate of 10 to the power of -4 and decay of 10 to the power of -6. I also Um, Also, since the model is going to be implemented into a website, it needed to have a small size. For this reason, uh, we used very high dropout rates, such as 0.2 and 0.4. Also, I trained this model with the dataset, with the aforementioned dataset with 20 epochs and 64 batch sizes. With these hyperparameters, the model is only 31 megabytes and it's quite precise. It's also now, other than the 12 layers, it's 16 layers. So we made the model longer. And this is the result of the deep neural network model that's actively in use on the website. As you can see from the confusion matrix and the rate table on the right, surprise and happy emotions are recognized with high recall. Angry is also recognized with fairly good recall rates, but neutral and sad are mixed up by the artificial intelligence. But this is actually expected since humans also find it hard to recognize natural and sad emotions from facial images alone. Precision values are pretty high all across board, and the overall accuracy of the model is, you can see it right now, but the overall accuracy model is nearly 86%. This is a lot higher than the similar projects in the internet. We tested these open source models, and they had around 70 to 75 accuracy by using the same testing model. And this is the Python code of the final model. If you're interested in other codes and training codes used in the project, you can contact me or my advisor, Professor Dr. Engin Tuncer, as well as our dataset. And this is the ending of my presentation. I thank all of my group mates, project members, and especially Professor Dr. Engin Tuncer for carrying out the project. Thank you for listening and have a nice day.